Many of us worry about what will happen when our lives come to an end. We see other living things die, and we know it will happen to us too. It's something we can't avoid, so we wonder when, where, and how it will happen. Some of us also think about the future of our planet, Earth. Will it always be a nice place to live, or will it be affected by changes like the sun getting bigger and hotter? Or could we harm our planet so much that it becomes a cold and empty place in space? If that were to happen, how long would it take? Would it be in 100 years, 1,000, or even 1,000,000? There are scientists called cosmologists who ask similar questions about the whole universe. The universe is incredibly vast compared to our planet or even our galaxy, and its history goes on for a very, very long time. Because of this, cosmologists can't be absolutely sure about how the universe started or how it will end, but they can look at clues, make educated guesses, and create theories to try and understand it better. Today, we're talking about the two fascinating theories that shed light on this enigma: the mesmerizing Big Rip, Big Crunch, and the mind-boggling heat death. But before moving to the video, like, share and subscribe to our channel and help us to get our first 1,000 subscribers. So let's move to our video. Imagine a universe that expands and evolves over billions of years. A cosmic tapestry woven by the forces of nature. We're talking about a surprising and intriguing theory that offers a glimpse into the possible fate of our universe: the Big Rip. The Big Rip stands as a theoretical scenario for the potential culmination of the universe, contingent on its elusive total density. Current findings from astronomers and physicists indicate a persistent expansion of the universe, with galaxies and other entities receding from one another at an accelerating pace. In physical cosmology, the Big Rip is a theory that describes the ultimate fate of the universe. According to this theory, everything in the universe, even spacetime itself, will be torn apart by the expansion of the universe until distances between particles will become infinite. Dickenson's hypothesis says that a Big Rip can occur when dark energy becomes stronger than gravity, reaching a point when it can rip apart single atoms. The sequence of events in a Big Rip would start with galaxies unraveling, followed by the disintegration of stellar systems, and ultimately leading to the fragmentation of atoms and particles, marking the universe's ultimate demise. Nonetheless, significant mysteries persist in our comprehension of the universe, enabling the formulation of speculative theories. Observable evidence suggests the universe's expansion and the separation of celestial bodies such as galaxies. This expansion rate displays signs of acceleration, indicating that a force beyond the initial Big Bang impetus is driving this augmentation. This phenomenon is often referred to as dark energy. The Big Rip hypothesis entails a progressive unraveling, beginning with substantial entities like galaxies coming apart, causing the constituent stellar systems to drift away from their galactic cores. This acceleration would lead to the disintegration of stellar systems and the departure of planets from their orbits, propelling them into the expanse of space. As the progression continues, the gravitational bonds holding stars and planets together would weaken, ultimately disintegrating these entities into particles and atoms. As the Big Rip approaches its culmination, even atoms themselves would face separation and dissolution. Nonetheless, recent data suggests that this particular model depicting the universe's end is relatively improbable. While the universe's density doesn't seem adequate for a Big Crunch scenario, it probably exceeds the threshold necessary for a Big Rip event. This concept is quite different from the Big Rip. In 1922, Russian physicist and mathematician Alexander Friedmann derived a famous set of equations aptly named the Friedmann equations. These calculations showed that our universe's destiny is determined by its density, and it could either expand or contract, rather than remain in a steady state. This shrinking will cause the temperature to rise, resulting in a very hot end of the universe. The universe continued to expand and thin out. You might be tempted to picture this young universe as a stew, with clumps of matter floating in thick gravy. But astronomers now think it was more like a soup, very smooth in density except for a few tiny fluctuations. These disturbances were just significant enough to cause matter to coalesce. Huge clusters of protogalaxies began to form. The protogalaxies matured into galaxies, great islands of gas and dust that gave birth to billions of stars. Around some of those stars, gravity pulled together rocks, ice and other materials to form planets. On at least one of those planets, life evolved. Some 11 billion years after the Big Bang started it all. Currently, the most favored hypothesis concerning the universe's eventual fate is termed the heat death. Within this concept, a heat death scenario transpires as the universe becomes so extensively dispersed that energy transmission becomes unfeasible, leading to a state of frozen equilibrium. The heat death of the universe is when the universe has reached a state of maximum entropy. This happens when all available energy has moved to places of less energy. Once this has happened, no more work can be extracted from the universe. Since heat ceases to flow, no more work can be acquired from heat transfer. This same kind of equilibrium state will also happen with all other forms of energy. Since no more work can be extracted from the universe at that point, it is effectively dead, especially for the purposes of humankind. Now let us think what this means for the universe. Any reaction that takes place will either result in the products becoming less ordered, or heat being given off. This means at some time in the future, when all the possible reactions have taken place, all that will be left is heat and fundamental particles. No reactions will be possible, because the universe will have reached its maximum entropy. The only reactions that can take place will result in a decrease of entropy, which is not possible. So in effect, the universe will really have died. The concept of an end to the universe is a topic of ongoing debate among scientists and cosmologists. However, it is important to note that these are currently just theories and there is no definitive answer as to what will happen to the universe. Additionally, it is worth noting that the universe is so vast and complex that it may not be possible for us to fully understand or predict its ultimate fate.